This engine didn't just make noise, it made history, changed careers, and nearly destroyed Chevrolet from the inside. The Chevy 265 Turbofire wasn't merely a technical breakthrough, it was a dangerous gamble. By day, it was hailed as a marvel of engineering, a compact powerhouse that gave Chevy a much-needed edge. But to the mechanics who had to deal with it after hours, it was a silent killer, a design prone to starving itself of oil and wearing itself down from within. And yet, drivers risked their lives for it. Why? Because it could crush Ford on the racetrack while tearing itself apart behind the scenes. The story of the 265 is darker, more dramatic, and far deadlier than most people realize. In the early 1950s, Chevrolet faced an existential crisis. Ford's 1954 Y-Block V8 was more than just a rival. It was an embarrassment to GM's top-selling brand, which was still relying on six-cylinder engines while nearly half the car market wanted V8 power. Chevrolet's general manager, Thomas Keating, had been warning GM brass for years, openly stating in a 1952 memo that the company had become too six-cylinder minded. The numbers didn't lie. In 1950, only about a quarter of new car buyers wanted a V8. By 1952, that figure was a third. By 1954, half the market was demanding it. GM's response was bold. A $1 billion overhaul of Chevrolet's production facilities, with Flint, Michigan chosen as the epicenter of this new engine revolution. At first, the project was under the guidance of Edward Kelly, the celebrated engineer behind Chevy's famous Stovebolt 6. Kelly's initial design was a smaller version of Cadillac's 331 cubic inch V8, scaled down to 231 cubic inches. It was close to production when the company made a sudden leadership change. Edward N. Cole, a rising engineering talent, was brought in to lead the project. Kelly was moved to oversee manufacturing, and Cole started fresh. Cole wasn't interested in tweaking old designs. He wanted a clean sheet approach. He saw that the Cadillac-style V8 was too heavy, too costly, and too limited for future upgrades. His vision extended beyond horsepower. He wanted an engine that was light, powerful, easy to manufacture, and cheap enough to mass produce without cutting corners. That meant reinventing not just the engine, but how the engine was built. One of Cole's key breakthroughs was in block casting. Instead of relying entirely on traditional dry sand cores, his team used green sand cores in strategic areas, especially in the valley between the cylinder bores. This allowed the block to be cast upside down, giving precise control over wall thickness and enabling incredibly thin cylinder walls, just 5/32 of an inch. The technique wasn't his alone. GM engineer John Dulo was credited as an equally vital contributor. The result was a lighter, more efficient block that could be produced with remarkable precision. Originally planned as a 245 cubic inch motor, the engine was enlarged to 265 cubic inches to compete in the 1950s horsepower race. Bore centers were set at 4.4 inches, creating a short, compact block just 21.75 inches long, remarkably small for a V8. Dubbed the Turbofire V8, it had an over-square design, meaning the bore was larger than the stroke, allowing for higher RPM performance. It featured hollow pushrods for oiling, stamped steel rocker arms, interchangeable heads, wedge-shaped combustion chambers, fully water-jacketed ports, aluminum pistons, and a forged steel crankshaft for strength. Its wedge-shaped chambers were especially innovative, with large quench areas that controlled detonation while creating turbulence for better fuel-air mixing. Spark plugs were perfectly positioned for fast, even flame spread, and a lip on the head shielded them from oil contamination. The engine's stroke-to-bore ratio of 0.8 to 1 reduced internal stress, improving durability. With an 8.0 to 1 compression ratio, high for its time, it delivered both power and efficiency, made possible by the increasing availability of high-octane leaded gasoline. But even this engineering masterpiece had its flaws. The valve train design, while innovative, suffered from lubrication issues early on. Engineers solved uneven oil distribution by slightly mismatching contact surfaces on the rocker arms to help oil flow and added metering devices in the lifters. 3 main oil galleries in the block ensured pressure was maintained throughout the system. The stamped steel rocker arm, originally a Pontiac development, was a cost-saving miracle because it required no machining and allowed the engine to rev safely to 6,000 RPM. Impressive for the era. Still, the design pushed the limits, and without perfect lubrication, wear became a serious problem. The Chevy 265 Turbofire was both an engineering revolution and a mechanical gamble. It gave Chevrolet the firepower to dominate on the track and in showrooms, but it came at a price. Beneath the glory was a design that, if neglected, could literally destroy itself from within. It was a legend, a liability, and the start of an engine dynasty that would shape the next 70 years of American performance.
Chevrolet's engineering team made countless small but impactful decisions to keep costs down without sacrificing reliability. Even details like the rocker arm covers received special treatment. Chief engineer Ed Cole insisted they not only perform well, but also look stylish, resulting in the now famous Chevrolet script elegantly stamped across the top. The Turbofire V8 wasn't just about raw power, it was an example of clever, efficient design. One highlight was the use of fully water-jacketed ports and lightweight aluminum pistons, which improved heat dissipation and allowed for a smaller, lighter radiator without compromising performance. The pistons themselves were of the autothermic slipper type, fitted with 3 rings and a circumferential expander behind the oil ring. This ensured consistent pressure to reduce oil consumption. Press-fitted piston pins eliminated the need for a split rod and locking bolt, simplifying assembly. Thanks to a short-stroke design, connecting rods were compact, and combined with aluminum pistons, the engine's reciprocating mass was reduced, improving responsiveness and efficiency. Chevrolet also innovated with a shorter, stiffer, forged crankshaft, which naturally reduced torsional vibration. Testing showed smooth operation across most of the RPM range, and a harmonic balancer handled the rest. A new balancing method was used. The crankshaft was partially balanced with precision machines, then fine-tuned by drilling tiny amounts from the counterweights to achieve perfect balance. The poised power engine mount system further reduced vibrations, using a 4-point setup that absorbed engine movement before it reached the chassis. At the front, strut-type mounts with stacked rubber biscuits were attached to the block and crossmember. At the rear, shear-type mounts connected the clutch housing to frame brackets, allowing flex to absorb torque and weight loads. The result was a noticeably smoother ride. But for all its brilliance, the first 265 V8 had serious flaws. Chevrolet launched it without a full-flow oil filter, offering only an optional bypass filter that cleaned just 10% of the oil. This allowed metal shavings, carbon deposits, and grit to circulate freely, rapidly wearing down internal parts. Many engines failed prematurely. By 1956, a full-flow filter became standard, but the damage to both engines and reputation was already done. Another weak point was the tight piston clearances. While efficient on paper, heat expansion in real-world conditions, especially in southern climates or under racing stress, caused pistons to scuff cylinder walls, crack skirts, or seize completely. Mechanics nicknamed it the scuffer. Lack of a PCV system, minimal breather design, and basic camshaft lubrication added to the issues, making early engines prone to oil blow-by and internal wear. Many historians now see the 265 as a prototype rushed into production to beat Ford to market. Still, in just 15 weeks, Cole's 2,900-person team turned the concept into a running prototype, and by 1955 it was in production. Offered in multiple configurations, the base 265 with a 2-barrel carburetor made 162 horsepower, while the Power Pack version with a 4-barrel and dual exhausts reached 180 horsepower. Later in the year, the Super Turbofire variant pushed output to 195 horsepower. Impressive numbers for the era. Compared to Chevrolet's 1954 inline 6, which took over 18 seconds to hit 60 miles per hour, the new V8 cut that time nearly in half. Demand was massive. By the end of 1955, 43% of Chevy buyers opted for the V8, forcing the company to expand production beyond its Flint, Michigan plant to Tonawanda, New York. On the track, the 265 shined. NASCAR legends like Herb Thomas, Buck Baker, and Tim Flock scored wins and pole positions, helping Chevy claim 38 NASCAR victories that year, far ahead of Ford. But even in racing, drivers admitted they were always listening for the death rattle of impending engine failure. In hindsight, the 265 Turbofire was a mix of genius and gamble, an engine that won races and cemented Chevrolet's performance reputation, but also carried design flaws that could destroy it from within. Had Cole's team been given just one more year, perhaps it would have been a flawless legend from the start. Instead, it became both a foundation for decades of small block dominance and a cautionary tale about rushing innovation to market.